today I'm teaching you the FEE assignment, okay, not BET. So in this problem number 1, they said a three-phase, whatever they have given, we have to write it like three-phase. It's a balanced connection, okay, and they have said that it's a star connected. So as you know, in case of star, line current would be equals to the phase current, and line voltage must be equals to root 3 times of the phase voltage, right? Then they have mentioned that voltage is given. Voltage, always they'll give you the line voltage, as I told you earlier also, and frequency also they have given, that is 50 hertz, correct? Now see what they have asked you in the question 1. They said if the load dissipates three phase power of X is equals to 10 kilowatt, right? So means load dissipates power, okay, of how much? 10 kilowatt. Whenever they'll use the word dissipation, okay, so in that case we'll use the formula P is equals to I square R. Power is given, that is 10 kilowatt, means 10,000 watt. Current we don't know, resistance also we don't know. So it's in my mind ki whenever they'll say ki dissipate, we have to use this formula, okay. Then they have said ki power factor means cos phi is how much, that is 0.84 lagging. So as you know the formula for cos phi, that is R by Z, correct? So cos phi is R by Z. If we know the value of cos phi, or if we know the value of Z, can we get the value for R? Yes or no? Or vice versa? So what they are asking then the per phase load inductance, means they are asking the L value, right? So basically we need to calculate Z. Z is equals to how much? As you know the formula, VPH is equals to IPH multiplied by ZPH. So VPH is VL by root 3. So 400 divided by root 3. IPH we don't know, and ZPH also we don't know, right? Okay, so this is one of the equation, but they have given us the power. Power is equals to, as this is three phase, so we can write it down as 3 IPH square and R, right? Yes or no? It's a three phase. So power is 10 kilowatt. So 10,000 watt is equals to 3 IPH ka square and multiplied by R. So this is the second equation. Next thing they have given that cos phi is equals to R over Z. So cos phi is how much they have given? 0.84 is equals to R over ZPH. This is the third equation, correct? So now we'll have three variables and we'll have three equations. One variable is IPH, right? Another variable is ZPH and another variable is R. So you can substitute it any way, so you can solve it. Three variables, three equation. This is third equation, this is second equation, and this is first equation, right? Like what you can substitute the value of R over here. So R would be here, you can 0.84 into ZPH, then here you can do it by your way. So basically we'll have three variables and three equations, correct? In question number 2, yeah, from here you will get the value for ZPH, right? So ZPH is how much? R plus JXL, right? ZPH you got to know, R you got to know, then you will be always also get to know XL, correct? And after getting XL is equals to 2 pi FL. So 2 pi F you know, XL you know, you will be able to get L easily. And they said it's in should be in millihenry, so you need to convert it into millihenry, okay? Consider the units also. Now in the next question, question number 2, they said if the load dissipates three phase power X is equals to 19 kilowatt. Means power is, again they have given 19 kilowatt, right? And at a power factor, cos phi is equals to 0.28. If then the total reactive power, as you know the formula, cos phi is equals to P by S. If we'll draw the power triangle, this is phi, this is P, this is Q, and this is S, right? So tan phi is how much? That is perpendicular over base, Q over P. So from here you can get the value for phi, that is cos inverse of 0.28, right? So you can get the value for phi. P already they have given. You can get the directly reactive power. Correct? Okay. Now after that, question number 3. In question number 3, they said if the power drawn by the load connected to R phase is 4600 watt, means they are particularly talking power across R, right? Like we'll have the sequence of R by B now. So they are saying power across R is how much? 4600. So in this case, we have to use P is equals to IR, right? We can't use 3 into I square because it's not for 3 phase. They are talking about only for the single phase, right? And the ammeter connected to the Y line means, yeah, for the active power only, when watt is given, then only you can use this formula. So then they said current in Y line reads 64 ampere. So IY is equals to 64 ampere, right? They said key 3 identical star connected coils are supplied with this, though, so this is also the balanced load, right? So can I say that if it's a balanced load, IR is also equals to 64 ampere, right? So current is given, power is given. Can we get the resistance? Power is 4600, I is 64 ka square, and R, your resistance, you can get it. Then they said magnitude of the reactance of the coil. Basically they are asking the reactance, means XL. So Z is equals to R plus JXL, right? So from here, Z is how much? That is VPH over IPH. R you already calculated from here. And can you get XL? How can you get VPH? They have given you VL. VL is 400 volt. So VPH is how much? 400 by root 3. I is here IPH only. Okay. Now after that, question number 4, right? In question number 4, they said if the power drawn by the load connected to R phase, power across R phase is how much? 5300 watt, right? And ammeter connected to Y phase means current across Y phase is 30 ampere, right? So as I told you, power is current is same. So P is equals to I square R. Power is given, current is given, we can get R. Then again they are asking the reactive power. So for reactive power we should have phi, right? Cos phi is equals to R over Z, right? R is given, we can get Z, then we can get the reactive power by any of the formula. You can do V into I, sin phi, you can use this formula also, right? So that depends on you. Got it? Next is question number 5. In this they said there is a 3-phase balance delta, right? balance delta connected load to a three-phase. Voltage is how much? 400 volt, and frequency is how much? 50 hertz. Correct? So as you know, in delta, VL must be equals to VPH and IL is equals to root 3 IPH. Right? So first question means question number 5. They are asking if the load draws an active power of 14 kilowatt. Power is how much? 14 kilowatt. Power factor is given 0.8. Then you need to calculate L. Basically, you need to calculate XL. For XL, you need Z, right? So tell me, if you have cos phi is equals to R by Z, or cos phi is equals to P by S, right? Cos phi you know, P you know. Can you get S? Yeah, then you can get Q. Okay, voltage is given, then you can get, right? So C will have the formula P is equals to VI cos phi, right? But it's for three phase, so we'll have the formula P is equals to root 3 VL IL cos phi. Cos phi is given, power is given, VL is given. We can get I, and after getting I, we'll have the formula VPH is equals to IPH into ZPH. VPH we know, IPH we can get it by IL, we can get ZPH. Okay, after getting ZPH, we can get Z is equals to R plus JXL. Z we know, R we can get it from here, we can get XL, right? That if we'll have power factor, so cos of theta V minus theta I, okay? Theta V is the voltage phase angle and theta I is the current phase angle. It is this thing. So they have given you cos phi. You can get phi from here by using cos inverse. So that is the angle between voltage and current. Got it? Now next is question number 7. They said consider supply line voltage as 310 volt. So what they have given, VL is equals to 310 volt, and the per phase stator winding impedance means ZPH is how much? 37 plus J70, right? If the stator winding are delta connected, means these are delta connected. Delta means VL is equals to VPH and IL is different. Then in that case they are saying the active power they are asking. So what is the formula for the active power? That is root 3 VL IL cos phi. So root 3 we know, VL we know 310 volt, IL we don't know, but we can get IL, right? So we'll have the formula VPH is equals to IPH into ZPH. So VPH is how much? 310. IPH we need to calculate, and ZPH is how much? 37 plus J70, right? So you can solve it like it's, you can consider it as an angle 0. Then you can put the value of IL there, to IL is equals to root 3 IPH, right? So whatever the value of IPH you are getting, divided by root 3. Now they are asking cos phi, convert this into the polar form. Whatever the angle you are getting, that is the phi only. Impedance का जो भी angle आएगा, that is phi. So you can get cos phi. So after solving it, you will get the active power. Now see in the next question, as you can see, the voltage, line voltage, question number 8. VL is equals to 360 volt. ZPH is equals to 62 plus J63. Okay, the ratio of motor active power rating when the stator winding in a delta configuration to when, yeah, basically they have given you need to calculate IPH and ZPH, right? For both, sorry, phi. For both the cases, for star and delta. Then you need to calculate power. Power is equals to root 3 VL IL cos phi. If I'll consider for the delta, the power is root 3, VL is 360, IPH we can get it by VPH by ZPH, so it's a 360 divided by 62 plus J63, and angle would be impedance का जो भी polar form में भी. And for the star it would be P is equals to root 3, VL is 360, IL is equals to IPH only, so whatever the value will get it, and cos phi. इसमें IL is equals to root 3 of IPH, तो ये तुम्हारा IPH आएगा, so multiplied by root 3. ठीक है. So what, see what you will observe, power in the star connection is equals to 1 by 3 of power in the delta connection. Okay, or we can say power in delta would be equals to power in star. So maybe it's the ratio of 1:3 or 3:1, that depends whatever they have asked. Got it? अगर इससे अलग कुछ आ रही है, that means your answer is wrong. Okay. Now question number 9, that VL is equals to 388.60 and P is equals to 11.20 kilowatt, and cos phi is how much? 0.77 lagging. Okay, the line current, they are asking the line current and they are asking in the delta configuration. So again we'll use the same formula, P is equals to root 3 VL IL cos phi. Everything is given, it's simple, right? Now last question, question number 10. Tell me how we can do this.